Um, okay, so I think everything's good. Okay. On the next slide, data encryption. So we just added this here, so that you guys will know that this is one of the branches that you can take using Python, right? That there is cybersecurity using Python, right? Where you test and also um look for vulnerabilities in other networks or devices, right? So that's one of those things is called encryption. So we won't actually go too deep onto this one, more like just a slight touch on this subject. Okay. Now data encryption, let's see. How does this work? In network communications, right? We call them data packets, and they are often sent over the network. And if they are sent over the network without encryption, right, it's basically like you letting everyone see what you're trying to send, right? So if you're trying to send something confidential, like passwords, for example, then you'll be exposed, right? So this is where data encryption comes in. And let's see here. So a sniffing software. So a sniffing software, if you try to Google this one, this is like those network analyzers, right? So they intercept data packets and try to read each packet that passes through over that software. And um depending on the encryption that you have, right? So if your encryption is actually good, it will either take them quite a while or it will take them just a few seconds, right? And with how fast everything is nowadays, our devices are quite capable now. Um, it usually doesn't take long before things can be cracked. There are concepts called keys, right? So one or more keys are used to encrypt messages to produce cipher text, and then to decrypt them, you also need those keys as well. All right. So here are two examples: Caesar cipher and block cipher. All right. So again, we won't go too deep into this one. Caesar cipher replaces each character in plain text with a character given a distance away. So here's an example, right? Um, our key here is three characters. So letter I, right? What comes after I? HIJKL. So that's why we have letter L here. LMNOPQ. That's why we have Q. So N to Q. So from this these letters, right? It becomes like this when you encrypt them. All right. So it's a rather simple way of encryption, right? But um in those days, right, in the past, this was already quite advanced, right? Not a lot of people were educated then. Okay. So only the ones in the know would be capable of actually solving this one manually. But again, it wasn't just as simple as just three characters. Of course, they're gonna use some other ways for it. Um, so this is what it looks like. If we were to apply this method today, okay? So as you can see, this is a plain text, A, B, C, D, up to Z, right? And we have ASCII values here, okay? Now, ASCII is short for American Standard Code for Information Interchange, all right? So you can search that one over. Basically, this is an encoding standard that uses 7 bits to represent 128 characters. So yeah, 128 characters. And this includes letters, numbers, and other special symbols that you have on your keyboard. All right. Let's see, if we search this one over Google, I think I've searched this one before as well, just to show my students. Yeah. So here, ASCIIcode.com. So we can see a reference, right? A kind of table that we have here. So this is the decimal equivalent. This is for the numbers. Wait, this is for the ASCII number, this decimal part, right? And oct, hex, and bin are just the different versions of the same decimal number, all right? This is the symbol that it is trying to represent. So let's just skip those things. Symbol, yeah. So here are the special characters. Here are the actual numbers that it represent and the actual letters that we're going to use, okay? So as you can see, ASCII here is basically just what you see on your keyboard, right? Everything that you see on your keyboard, and that's included in the ASCII. Okay, um, and more actually with these things here. I don't really use these things as well. But let's go to the small characters because in our example here, we are using small characters. Okay, so letter A is at ASCII value 97. So if you go to the table, 97, that's correct. It's over here. Okay. The two columns here, HTML number and HTML name, these are used for when you are developing them on the web. You're making a website or a web app, something like that. And it has an equivalent um code that you can use to represent that symbol. Okay, so instead of using the decimal code, you can represent it using this code to make it appear. Okay, to make that symbol appear. Okay, but no need for us to actually be um, familiar with this right now. The last column here is just a shortcut. So instead of writing ampersand pound 123, you can just type in ampersand lcub or word bar, those kinds of things. Okay. So that's basically it. So what's very important here are the two columns called decimal and symbol. So we'll focus on those two columns. Okay. And if you see this one, right? Okay, so A move three characters to the right, okay, is A, B, C, D, so it's letter D, right? It also corresponds to the decimal value as well, right? Because as you move the letters, the ASCII value should also move to the right by one. Okay, so why are we trying to represent it in ASCII values? Because um the computer doesn't understand the letters themselves, right? Remember, computers can understand only ones and zeros. So we have to find a way to represent those characters as well. So that's how the ASCII values came about because we were trying to send characters over the internet, right? And if we were just trying to use regular numbers, one to um all the characters in the alphabet, right? It wouldn't take into account the other symbols, the other characters, right? So they have to make a kind of system. That's what the ASCII is. Um, ASCII is just a bigger part of a whole. All right. So it's called Unicode. Okay. Yeah, I think I use this one. Home Unicode. All right. So Unicode, right? Uh, is the universal reference that we're gonna use if we want to like get the character set for other languages. Okay, so for example, if you're going to use Japanese, so you can find it somewhere around here, I think. Here's the one for Chinese. I think. So it's under U plus 93 U1. Okay. But ASCII code is also part of Unicode, right? It just so happens that we're just primarily focused on Unicode right now, on ASCII right now. Okay. So Unicode, it's part of ASCII. No, ASCII is part of Unicode. And yeah. So if you are in another country, odds are they'll be using a different character set there because their keyboards are different. Okay. So they took that into account when sending information through the internet instead of sending the ASCII values because that's what almost everyone uses. If their keyboard is different, so it has a different character set. So it'll be using the ones from Unicode. Okay. All right. Let's get back to our example here. So, let's see. All right. Mm, okay. So this is now our ciphertext, right? LQYDGHUV. So that's called encryption. And the opposite way is from this here. If you were to use the key and go to the left, right, for each character, we call that decryption. And it's still the same thing in the modern day. We still call it decryption and decryption. Mm, so we have this kind of program here that we can use, right? So if you follow this code, it will um simulate the one that we are trying to discuss here. Okay, so let's try and see each one. Okay, so it has a different script. It's called encrypt.py, right? And let's take it into account, right? Let's try and analyze each one. So input is just it's asking for input. So enter one word, lowercase message. Next is it's asking for the distance or the key that we are going to use. Next is it has a blank variable called code. So this is where we're going to store our encrypted message, right? So for CH in plain text, right? So it's gonna take a look at each character from our original text. It's gonna use the function called OR. So this is the um, key functions that we're gonna use. So let's try to take a look at what those things do. The ORed here, ORed function. That's just an AI. Okay. So returns the integer that represents the number, the character H. So in other words, the number represented the Unicode code of a specified character, right? So therefore, you see the Unicode there. And well, that's basically it. So it's actually that simple. It just returns the Unicode. And the other pair is CHR. So CHR here gets the character that represents that Unicode. Okay, so 97. So the one that we were looking at earlier, right? The ASCII code. Remember, ASCII code is just um part of Unicode, right? So whatever you're using in ASCII is already part of Unicode. That means you can just plug it in directly here like this. The decimal, that's the decimal equivalent. So that's why we can just plug in here 97 and then it will give us the letter A. All right. So using that concept, ORD and CHR to switch between Unicode and to the character, right? The letter. Um, that's what we're trying to do here. So you're trying to get ORD, right? You're trying to get the Unicode equivalent for that letter. You add a distance to that, okay? Because you can't add a number to a letter, right? So you have letter A, and then you can't add a distance of 3 to the letter A, right? Because it's not gonna work. It's a different data type. So they have to convert it first to Unicode. You understand? That's the importance there. Next is if cipher value, where's this one? Is greater than the ORD of Z. So basically this part, it looks complicated, right? But what is ORD of Z? So ORD is what again? ORD is the conversion from character to Unicode. Okay, so it's taking a look at the last character. So it's trying to check if our current cipher value is greater than the letter Z. Why? Because what comes after Z? Okay, Unicode. Unicode. No, no, wait. It's ASCII. Let's go to ASCII. It's a shorter list. Okay, here. So what comes after Z, the small letter Z? What comes after it? It's the uh open curly brace, all right? So that's not one of the letters anymore, right? So what do? We have to have a logic in our code that after letter Z, it has to go back to letter A. Okay. So for example, you are at 122. Okay. So if you're if the letter, for example, was Y, right? And then your key was 3. So 121 plus 3 is 124, which is wrong, right? Because it will give us this pipe. So what you need to do is after 123, right? 123 goes back here, right? 24. Okay. You understand? So it goes back to letter A and so on and so forth. So this code here, although it looks complicated, it's actually just a way for us to go back to letter A. Okay. Um, so yeah. Or plus yeah, so as you can see, it's trying to get the current value of it and then deducting the value from that from that Z in order to give it to make it go back to letter A, right? Um, yeah, to make it go back to letter A. So um the one that will appear in our cipher after this logic here is letter A. Okay, after Z, it should go back to A, and so on and so forth. And if you print that code, also, okay, so this is still decrypt, the same thing, right? Exactly the same thing, but in reverse. Okay, we're still gonna get the input. We have the plain text, same thing. We're gonna get the ORed values. We're gonna this as I said with plus, it's gonna be using minus. Okay, the same logic that we used before. If it goes over Z, it should go back to letter A and then add it back to our variable here, the holder of our decrypted text this time. So decrypt file and then the other one was encrypt. So if you use them together or in just one file, there are two different functions, then this is what the outcome would be. So enter one word, lowercase message, invaders, enter a distance of 3. So this is the encrypted message now from invaders to this one. Next is this is the part where we're using the decrypt now. So enter the coded text. This is the encrypted text. Enter the key 3, and then you will get the original message, which is invaders. Okay. Um, so one thing wrong here in this PowerPoint is that since it's using PowerPoint, it automatically makes it capital at the beginning, but it should be small letter, right? So that's just a typo. Um, Caesar cipher worked well in ancient times, but it's easy to break using modern computers, right? So you see that warning whenever you create a password where it says your password is too weak, right? Because that's actually true. Okay. Um, if you were unfortunate enough to encounter someone that has the ability and has the knowledge to actually decrypt stuff, right? Then they can do it by using a smartphone or a laptop, okay? But if you have a password that is really complex, right? Um, that has almost all the characters possible on the keyboard, like it has symbols, uppercase, lowercase, numbers, and various combinations of those things. So up until 16, I think 16 is the minimum these days for a really secure password. Let's see. Yeah, it will take even supercomputers a whole lot of time before they can decrypt that one. So yeah, if you have a secure password, right, all you have to do is just secure it somewhere. This is why other um other individuals resort to other tactics rather than decryption because it takes a long time. So what they resort to is what we call phishing. There's also malware attacks because it's usually just easier, right? To prioritize on human mistakes like clicking on a link or signing up for something, right? So those kinds of things. It's actually much more effective than decryption, which actually takes a very long time. I wonder if we can search this one. How long to decrypt 16 character password? I think there's a computation here. Yeah, so here we go. Don't use characters 14. So 16, yeah, I'm correct. So 16 will take a hacker ability yours to crack. All right. So if you want to secure something, make sure it's about a 16 character password and then just store it somewhere and just refer to it whenever you want to use it, right? Okay. Or if you can memorize it, that's good as well. Um, so yeah, this is from actually Bitwarden, so it's one of those apps that protect your devices. So yeah, how secure is a 16? Great security, more, yeah. So different sources are actually saying that it is correct. Right. So 16 characters. So better review your password, guys, for those important accounts. Block cipher. All right. So it's uses plain text to copy two or more encrypted characters. Each encrypted character is computed using two or more plain text characters. All right. And it uses an virtual matrix. So I'm not really sure what this one is, as well. If I were to think of an example, this would be what you see on your routers, right? So if you ever try to explore your routers, you would be able to see something like um, AES, Advanced Encryption Standard, and sometimes they make you choose how many blocks, like 64 or 128 blocks or bits, and then that's the kind of encryption that it's gonna do. I think some phones actually have this one as well when you're using data. Um, yeah, so I think it also has an option there. Depends on the phone. So yeah, you can just search around on your settings for this. So it won't be block cipher. I think most likely it will be AES. So just search for that one. AES on router. Yeah, yeah. Okay, so Wi-Fi, but yeah, it's part of the Wi-Fi protected access to protocol WAP PA2, right? So you can just search this one if you want to know more. Okay, so if data science is not your thing, maybe cybersecurity is, right? Let's see. Strings and number systems. All right. So we're down to the conversions of those things. Okay. Arithmetic operations use the decimal number system, right? So we are using the decimal system, the base 10, right? Binary is using zeros and ones. Octal is using the base 8, okay, from the word octal, 8. Hexadecimal is using base 16, from the word hexa, so 16 numbers, all right? But hexadecimal, it includes letters, okay, because it ran out of numbers as using letters. All right, we have the decimal here on the left, and the equivalent representation of that decimal number on the right in binary and octal and decimal and hexa, right? So 415 is looks like this. There's a typo at the end. Octal is 6378. Decimal is 415. Ah, okay. So I think I know what the typo is. This should be a subscript. That looks it should be in the bottom here. So 2, this is 8, this is 10 below, and then this is F16 at the bottom. So it's kind of a notation where uh, it reminds the reader that the number that they're looking at is in that specific notation. Okay. Um, yeah, so the last number here are subscripts. In this case, it's 10, and in this case, it's 16, right? So you might be asking why they were invented in the first place, right? Because if you think about it, decimal is already enough for us, the 10 numbers, 0 to 9. It's not 0, it's not 1 to 10, okay? It's 0 to 9. So just making sure. So the reason why these number systems were invented is because I think I said this before, the memory during the early days, right, of our computers are, um, it's very scarce, okay? So they needed a way to represent numbers in a more convenient way, okay? It's in a more readable way, and it's more efficient in terms of regarding memory and also for error checking, right? So think about this one, right? Um, think about binary notations, for example. Okay, so we can, of course, represent the binary into decimal, right? Because if you think about how many characters, right, does it take to represent the binary notation? So there's a lot compared to decimal, which just takes 3 characters. So it's much easier to see this one. It's much more readable compared to this one, and then it's much more efficient in terms of using the memory and also for error checking, right? Um, like what else? So memory addresses, for example, are quite long. Like if you've ever seen the blue screen of death or the BSOD example, let's see. Yeah, this one. All right. And then if you click on one, usually there are, yeah, see this one at the bottom. So 0x0000C1, those kinds of errors. Okay. If you've ever encountered this one, it's usually because of the memory, something in the memory. And then, I can't actually make it any bigger than this. So in order to represent the memory address, they have to use hexadecimal because it's actually quite long. So using it in hex is actually easier for us to read. Even though it looks difficult, it's actually the easier version of reading the memory address. Okay. So how do we convert it? So that they just use an HSMR counter from 0 to n-1, where n is the system's base, right? So we have, how many bases do we have? We have base 2, base 10, base 8, and base 16, right? Um, to represent the is vast rather than 9 of base 10, like base 16, what we do is go with letters. So like hexadecimal, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So that's 10 characters. And then after 9, it's A, B, C, D, E, F. So at F, that is where uh, the total count is 16, right? So that's what we do. After 9, we go to letters A, B, up until F. All right. So here's an example, right? If we were to solve it manually using by hand, okay, using positional notation, right? It's based on position, and then determine by raising the base to the power specified by the position base to the power of position, right? So position is where the number is based currently. So for example here, 415 base 10. If we were to expand this one, right, and convert it into base, uh, what base? Okay, it's just trying to show us the equivalent in base 10 notation. So if we were to expand this, it would look like 4 times 10 to the power of 2, 1 times 10 to the power of 1 plus 5 times 10 to the power of 0. All right. Now remember, in our lists, right? And indexes always start at 0. So it's also the same thing here. So take a look at the top, 0, 1, and 2. So those are the positions, right? The rightmost part is 0 position. Next is 1, next is 2, right? So these are their positional values. This is the base, right? 10 to the power of position, 10 to the power of position 1, 10 to the power of position 2, multiplied by whatever the value is on that position. So we have 4, 1, and 5. If we were to convert that one here, so we have 4 times 100 times 10 and times 1. And then simplified further, 400 plus 10 plus 5, and then we have 415. All right. So these are the positional values if we converted it, right? 100, 10, and 1. All right. So does these numbers seem familiar, right? So in our basic mathematics, right, when we were trying to learn numbers before, we always discuss the how to in how to read numbers, right? We always say this is the ones place, this is the tens place, this is the hundreds place, and then the next one is the thousands place, right? That's how we learned before in mathematics. And this is actually the reason why they are called that ones, tens, and hundreds. It's because of their positional value. So I hope you guys can relate with me on that. I don't know how they teach it in other schools, but that is how we were taught. And with my other students, they also responded in the same way. So maybe it's the same for you guys as well. Mm, so this one is using base 2, right? So it's the same thing. Start with a number multiplied by the base to the power of its position. So we have 7 numbers here, so it should be 0 to 6. So 0, 1, 2, 3, 4, 5, 6, and then those are the powers, right? The exponents. And then we have the base of 2 because we're trying to convert it. Okay. And as you can see here, right? If we simplify it further, we get 64, 32, 16, 8, 4, 2, and 1. Um, so I don't know if you guys are seeing a pattern here. Okay. Um, but let's go back to that later. Okay, simplify it further, it's 64, 32, 4, 2, 1. So the zeros are removed because it's just zeros, right? Equals to 103. So this number here, this binary number here that is in base 2 is equivalent to 103 in base 10 in decimal. Okay. All right. So let's go back to this one. Um, so you're using computers, right? And then you must have heard somewhere a description about your processor. So it's gonna be something like um 32-bit processor or a 64-bit processor. Okay, 32, 64. We don't have a 128 yet, but um, I don't know if that will come. But this is the pattern that it's trying to follow. So 16, I don't know if there's a 16. Maybe the very older processors, had 16 and 8. I'm not really sure because it became prominent at 32. And then followed by 64-bit, which is what almost everyone uses right now, the 64-bit CPU architecture. All right. Okay. Mm, all right. So there's really no need for us to actually understand this one. It's more like it's just trying to show us what happens underneath, right? When we try to convert, all right, this logic here into code. So basically, it's just giving us a code on how to achieve that one using Python. Okay, so let's analyze this one a little bit. Again, there's no need to memorize this. There's an easier way in the end that I'll teach you. And I should prefer that one. Yeah, rather than this. So we start with an input. We enter a string of bits. We start with decimal is equals to zero, right? Because currently we're not reading anything. Next is exponent is equals to len bit string minus one. So what is len? It counts the number of strings, right? But it counts starting at one, right? It's not starting at zero. So meaning len bit string is actually one character more. So that's why we have to put minus one here to make it correct. All right. Four digit in bit string. So it's trying to look at each character in our um binary string here. Okay, our binary string. And whenever you're using a for loop, right, it always goes from left to right. So our exponent must also start what? At the leftmost part of our position. So it should be decimal plus, um, yeah, decimal because we want to add it to our current decimal value. So int of digit, right, is converting the bit here to either one or zero, right? Take a look, one or zero. Okay. And then multiply by 2 to the power of exponent. Okay, our current exponent is len of bit string. So in this case, if you're trying to follow this one, len is 367. Minus 1 is 6, so that's correct. 2 to the power of 6. That is our first positional value here, right? Then add that to decimal and then put it back to the same variable, decimal. Okay. After that, we um, deduct 1 from the exponent, okay, to make it go to the next one, which is this. Okay. And just repeat the process in that loop. So it keeps adding up to our decimal value here, decimal variable. Okay, it keeps on increasing on each loop. And then finally at the end, it will just be printed out like this one. So here's an example. Enter a string of bits, 1111. The integer value is 15. Here's another one, 101. The integer value is 5. So just a quick check. 1, 2. This should be 1, 2, 4, and 8. 8 plus 4 is 12. 12 plus 2 is 14. 14 plus 1 is 15. So this is correct. This one is easier. 1, 2, and 4. So 4 plus 1 is 5. So you got 5 here. Okay. 0 is excluded because 0 times anything is 0. So I didn't add the 2 there. Okay. All right. But again, yeah, you don't need to focus on that one. Okay. Decimal to binary. So now it's the opposite. We're converting it into the opposite sign. So how are integers converted from decimal to binary? Okay. So one algorithm uses division and subtraction instead of multiplication and addition. So these are the basic steps that we can follow. Repeatedly divide the decimal number by 2. After each division, the remainder either is what is placed at the beginning of the string of bits. Quotient becomes the next dividend, and then the process continues until the number is greater than the process will continue while the number is greater than 0. So all we need to do is convert this process into Python code. Okay. Now let's take a look here. Um, Same as before, we're gonna ask for a input, and that input is a decimal integer, right? Um, and we're gonna convert it into an actual integer. So if decimal is equal to 0, then we'll just print it to 0. Otherwise, this is where our logic comes in. So print quotient remainder binary. That's the name of this process. Quotient remainder binary. So let's start with the regular bit string. Okay. Remember this is in string format because if you were to actually type in the actual bit string as numbers, then it's not going to be the same thing. It should be in string format. Okay. While decimal is greater than 0. Okay. So first thing that it does is what? It divides it by 2. Divides it, divides, and then the remainder. All right, there we go. So it's using the modulo operator. Okay, you use this one, the percent sign, to get the remainder when you're trying to divide something. And then you also get the floor division. Okay, so if we were to try and divide 5 divided by 4, that would give us a remainder of 1 and then a decimal of 4. Okay, so I hope you understand. Um, yeah, so we have a remainder of 1 and then a decimal of 4, and then that decimal will be used again later on as no, the next part of the computation. But we have to add it first, the result. We have to add it to our bit string. So string remainder plus bit string. So this part here is not actually a plus. Plus, it's a concatenation. So we're trying to add two different strings. Okay, so as you can see, we're converting the remainder into a string data type and then add it to the current string that we have here. So eventually it will just be what? Ones and zeros. Okay, we're gonna print it out, percent %d. So we're just formatting it in a way. Um, and what we will see in the end is the final bit string. So basically it just shows the decimal, afterwards the remainder, and then the bit string. So this is the entire while loop, right? From here, while loop up until this one, we can kind of get to see the actual flow of our program here. Okay. And then after the while loop, right, it keeps on repeating this one and up until we reach a point where we get the division, right? And then we get the whole number, where the whole number is now equal to 0. And when that happens, right, it will exit out of the while loop and then goes to print the binary representation as bit string. So this is the part where we'll see the final answer. So that program looks kind of like this. Enter a decimal integer, 34, and then it starts with 17. So 34 divided by 2, you get what? What's the sequence? Decimal, remainder, and bit string. So since this is an even number, right, it will give us a 0 remainder. Okay. And then this is the new whole number that we have. And this is the current value of our bit string here. Okay, the last part. All right, now let's keep on going. 17 divided by 2, we have 8, remainder 1. Okay. And then if we add 1 now to 0, what will we have? It's 1, 0. Let's keep going. 8 divided by 4. So 8 divided by 2, we have a whole number of 4 and a remainder of 0. You add 0 to the previous string that we have, so it's 0, 1, 0. 4 divided by 2, we have 2, remainder is 0. 0 added to 0, 1, 0, we have this one. 2 divided by 2 is 1, remainder 0. Add 0 to this one, we have 0, 0, 1, 0, up until we reach the point where it's 1 divided by 2, right? You get the whole number of 0, remainder 1. And you just add 1 here to the beginning. So this is the final answer, the representation of 634, the decimal 34 in binary is 1, 0, 0, 0, 1, 0. If we do a quick check, so it's 1, 2, 4, 8, 16, 32. So 32 plus 2, it's 34. So this is correct. Okay. So I hope everyone understands. Any questions so far, by the way? So everything is in the PowerPoint, really, even the examples. I just didn't put it in the Jupyter because, we're not going to be using those programs anyway later on. We're going to be using something else. All right, so here's a quick chart if you guys have no questions. Um, just a quick reference, right? If you want to memorize it for the basic numbers, 0 to 8. So 1 1 0 1 1 1, those kind of stuff. And we're gonna go now to octal and hexadecimal numbers. So how do we compute them? So for octal, right, each number is equivalent to 3 bits in the binary number. So all you have to do is convert each number to their binary equivalent, and it looks like this. So that's how you convert from an octal number to binary. Okay. So yeah, assume that each digit in the octal represents the 3 digits in the corresponding binary number, and then just combine them together like this. So um that's your binary number equivalent. Okay. So to convert binary to octal, you begin at the right, factor the bits into groups of 3 bits each. All right. So if you were to go in reverse, then all you have to do is divide your binary string into three. If you are left with just one character at the end, then just put some zeros and then it's all good as well. The same thing goes for hexadecimal, but instead of grouping it by three, you're going to be grouping it by four. Take note, this is not from decimal, okay? This is from octal to binary. This is from hexa to binary. It's not into decimal, right? These are not decimal numbers. You're going to have to convert them again to get the equivalent, okay? Right, so the same thing, do the same thing with hex with octal, all right? Let's see. String method. So we're finally done. Okay. Now let me teach you a better way to convert those kinds of numbers. All right. So what we're gonna be using is our um let's see, our int function. So let's start with binary to decimal, for example. Okay. Then we have um an input, right? So let's say we're gonna ask the user for the binary string, right? And then since this is a binary, so enter a binary number. Okay. And then what we do, we get the decimal value for this one. Value is equals to int, right? Now, usually the int, right? We put the character in and then it converts it to integer equivalent, right? But what we can do here is there's actually second a second argument that it has, and it describes what the base of the number that you're trying to put in. So in here, in this case, it's binary, right? String. Okay. Um, this is in base 2. So I'm telling the function that the binary string here is in base 2. So if I were to convert it, right? Let's see. I'm gonna print it out here. Print decimal value. Let's run it. So what example did we have earlier? Nope. Nope. Let's see. Yeah, so let's start with this one. 1 1 1. It should be 7, right? So enter it. Okay. So it printed out that error because it's blank. 1 1 1. And there we have it. It's 7. Okay. So you can just use the int here, right? If you're just trying to convert any number system into decimal, you can just use the int um for that problem. Okay, whether it's gonna be binary to decimal, It's gonna be octal to decimal. It can work. So instead of two, you're gonna use eight, right? Decimal, and then um hex to decimal. It will also work using this strategy. All right. So if we say an octal number, for example, then all we have to do is change this one to eight. And then let's take a look at an example here. So, no, not that one. Octal number equivalent. Yeah, this one here. So we have 637. It should be equal to 415. So where is it? Yeah, if we run this one again, 637. Yeah, it's equal to 415. Okay. And finally for hex, so 16, right? On our PowerPoint, it's 19F, right? So let's clear this one up for now. Oh wait, it's gonna clear up later on. So 16, right? And then 19F. If we were to convert that one, it's still gonna be 415. So we know now that our examples here are actually correct. Okay. Let's see. So yeah, we're done with binary, octal, hexadecimal. So we're missing decimal to binary. So this is something different, okay? It's not just one function, it's three more functions. So decimal to binary, and then there's also decimal to octal, and then decimal to hex. All right. So we're going to be using the appropriate functions that belong to them. So we're just going to have an input here. So one input for all of them. Let's say decimal value here is equals to input int of input. Enter a decimal, right? And then if you want it to be converted to binary, then I'm just gonna print this out directly, okay? Um, then we're gonna say bin and then just plug in the decimal number there. Next is the octal. So all you have to do is use the oct and then plug in the decimal value. I'm using the wrong one. Decimal value, decimal value. And then finally for the last part, you're just gonna use X and then decimal value as well. So this is actually much easier, right? Um, let's see. So print, right? This is string of binary. So I'm just adding some indication here to separate one output from the other hex. Right. So let's run a code. It's 415, right? So here are their equivalents. Now, when you're using these functions, bin, oct, and hex, there's going to be two extra characters in the beginning indicating what number they are. So the actual answer here is starting from 1 up until here. Okay. From octal, it's after the letter O, and then for hex, it's after the letter X. Okay. So 0B there is just an indication that the number that you are reading is in binary. uh it's in binary format. 0 O is an indication for an octal number. 0x is an indication for a hex number. So now you know that whenever you see an error that has a 0x in the beginning, it's actually a hex number. It's a hex representation of the memory address that you have. Okay. So that's it basically. You don't need to remember all those formulas from before. You just need to remember four functions. Int, okay, for anything to decimal, and then bin, oct, and hex for their equivalent decimal to that base number conversions. Okay. So overall it's four. Int, bin, oct, and hex. All right. Okay. So let's go back here. We are currently at split methods. Okay. Mhm. All right. Any questions so far? All right. So that's great. The questions. Okay. So right now we are at string methods. So I hope you guys still remember what methods are. So again, methods are just functions that work on that specific object only. All right. So we're going to be focused on string methods. So these methods will work only on the string object. Okay. Any kind of string as long as they are a string. Okay. So we have a program here. Sentence is equals to input, enter a sentence. The user has entered this one. The sentence has no long words. It's using the split function here. Now the split is just uh the split is a string method that can convert it into a list. Yeah, because it will be split into a per word into a list, and then it's counting out how many words there are on that list. So it's using len list of words. And then there are six words in total. So this is correct. One, two, three, four, five, six. Okay. For word in list of words. So it's trying to check the length for each word, and then it's trying to give us the average word length. But this is outside the topic. The important part here is the split, all right? So let's have one example here. So let's say we have that kind of string. Let's make it simple. And if we were to print this one out, print temp. Okay, I'll sign this one as temp. I thought it's spread. It's violet. Um, print temp dot split, right? And then this is what we get. Okay, it will split um the word using the default character. Now, the default character for split is what? It's actually space, right? Um, so that's why it's splitting the words up because it knows that we have a space separating each word. So if I were to remove one of the spaces, right, it will look something like this. Okay. So what if, right, our string was, if we're just gonna explore this one a little bit, what if our string was something different, like it separated each word with colons, for example? A common thing that you will see whenever you're trying to gather data for your data science projects, right? And if we were to run this code using the normal one, it's just going to give us the whole thing, right? Because the default for a split is a uh split is space. So if we indicate here a character that you should split it in terms of the colon, right? Whenever the colon is appears on the string, split it there. So this is what we'll have, okay? So this is really great if in our data science projects later on and you're trying to split data. And then that data is in this kind of format. So depending on where you got it, the data is represented like this. Like, for example, if this was a survey for the statistics office, this would be gender, religion, age, those kind of stuff, right? So depending on what kind of information you're working on, really. So that is the split method, okay? We're not gonna be dealing with all the methods possible, right? I'm gonna leave it up to you guys to explore them further, right? There's a lot of resources on the internet for this. So you can just search string methods, Python for this, and then it will give you a lot of things. So again, this site comes up again. Okay, and you'll see a lot of things, okay? Again, these things work for what? It will only work for strings. So you have to remember that one, okay? All right. So you can um explore how the other functions work. Okay, the ones that are not found in our PowerPoint. Okay. The important point here is how to use those methods, not on what method we're trying to learn. Okay. Um, the important part is how to use those methods, okay? And since you already know how to read functions, right? Then you also know how to read methods because essentially they are the same, right? And then each one there, if we go to split, or split here. If you go to split that, it will also show you the same thing, like the syntax and also the parameters that it has, okay? And the arguments that you need. So it's the same thing, really. Um, let's see. Where am I? Here. Okay. String methods too. Then we have all right, so it's just the so we already know this one. An object knows about the internal state. Yes, but this isn't actually important for us right now. We don't really care about the internal state of the object currently. All data values are objects, see? And yeah, you can also use dir and help in this case, right? But you have the internet for this. Why would you use this one? But for the sake of example, let's just try and see. So if you were to say dir of um temp, right? This is what you will see. And what you will see is what the object, right? The properties and the methods available for that object. Since the object is a string, then it will show us all the properties and methods for strings. Okay. If you were to use the help here, help, right? Let's say help, and then you're trying to search for some help for the split function. So all you have to do is temp dot split without the open and close parentheses, run it, and then it will give you the description. Okay. What you will see here is exactly the same as what you see here. It's just represented in a different format. All right. So when set to none, we'll split on any white space. So it didn't actually include this here. Or I think, oh yeah, by default, any white space is a separator. There we go. So, including those things, we have the new line, we have the return key, so the enter key. You have the tab and the F. I forgot what the F is, and spaces. So it will be discarded. Maximum number of split. So starting from the left, I think the default value here is -1. Yeah, default is -1. But if you want to split it in just a few occurrences, then you can actually use the max split parameter. Okay. Um, Mainly used for data that has been intentionally delimited. Okay. With natural text-like punctuations, consider using a regex module, right? So take note of the keyword intentionally delimited, right? The one that has the information or the data stored the data into one string, but they just separate it into different slashes. The same thing with addresses. Like take a look at this address, for example. It's separating each section by slashes. So you can actually use it here as well. All right. String methods 3, split of the dot. Okay, so what it's trying to get is it's trying to separate the file type and the file name. Okay. Then we have the subscript extracts the last element of our um list. So can be used to write any file names extension as follows. Okay, so I don't know why it's using -1, but I think it's just for the sake of example. If you have a file name, can you have multiple dots in a file name? I don't think so. I think you can only have one dot in a file name. I think this depends. Okay. We're assuming that the dot will only appear once, and that is before the file type. Mm, I'm not really sure if this will work for files that have multiple dots. Yeah. So that's why it's using the -1 here because it will always choose the one at the very end. So you can be sure that what you're choosing is actually the extension of the file. All right. Text files. Okay, so we're now going to text files. Actually, um, let's have an exercise first because I think we're too far deep now. Maybe you guys will forget the lesson from before. Let's have a quick exercise about substrings before we proceed to text files. Okay, let's see. All right, so for your exercise, all right, so just a simple one. This will be in Markdown. Okay, so write a program that checks if a user entered word is a palindrome. We use the same forwards and backwards. Use string slicing and the input operator to perform the check, right? So a palindrome is just a word that reads the same way backwards. Like for example, your word is ABBA, the band ABBA. Then if you were to read it backwards, it will still read as ABBA, right? A. So yeah. Um, just create a program that will check if the word is actually a palindrome or not, right? So I guess 10 minutes is enough for this. That way we'll have more time for the second exercise. Okay. All right. Your timer starts now. Okay, so it's 2:33. Does anyone have an answer? Hello? Hello? Anyone? Guys? Sir June? How about you, Sir June? Do you have an answer?
Yes, sir.
All right.
Sir. Good afternoon, sir. I'll just share my screen, sir.
Okay.
Can you see my screen, sir?
Yep.
Uh, so here's my code for the palindrome test.
Mm.
So first, first thing I did is define a function to test the word if it is palindrome by converting first the word into a lowercase and then returning if the word the start and the uh movement is -1, that means it will test in a reverse way.
Mhm.
So then next is we will get the input by entering a word, and then by condition, if the if if this is true, then the word palindrome will print the word plus is a palindrome, and then else the word is not a palindrome. So let's just test this. Let's say for example level.
Mhm.
So
All
the
right.
word is palindrome.
Okay.
So
So how about another example, sir?
so let's say word
All right.
is not a
Not
palindrome.
palindrome. All right. So good job, sir. How about the others? Do you have a different way of getting the output, or does it look similar to what Sir June has? Actually, my solution is similar to what Sir June has also. How about the others? Do you have a different way of solving this exercise? Sir Ryan, yes, you want to say something?
Yeah, sir. I have a uh, almost similar answer, sir, but it's in a more shorter way.
All right. Okay. Can you please show us?
Just a minute, sir.
So thank you for that, Sir June. All right.
This
So,
is, do you see now, sir, my screen?
yeah. All right.
Uh,
So the difference
Sir,
is,
Sir Jun's method is he created a function.
mm,
For this one, it's much a shorter way. I just input. I just created a variable where the user's input will be stored. So straightforward it to comparing these operations from it checks the letters that are inputted from the user. -1, uh, it will check if the same letters are the same reading backwards. So if the same letter when in checking from right to left.
all right.
So for example, sir, like madam, this one, and sir from for example book. So from left to right, it compares. From right to left, it confirms. It checks if these letters are the same.
All right. So yeah, it's true. It's about a few processes more efficient compared to Sir June's work. So yeah, um, this is also correct. Good job on this, sir. But like I said before, Um, let's not focus too much first on efficiency, especially when we're still learning Python. Because there's a lot of time later on, especially when you're done with everything, right? That's where refactoring comes in, where you're trying to make your code as smaller, as more efficient as possible. So yeah, both of your answers are correct, and with Sir Ryan's answer being the one more efficient. So good job on this, guys. All right, so let's have one more. All right, before it's three, and then we'll have a quick break. Let's see. Where is my okay, there. Uh-huh. Okay. This one is actually it's still a bit easier, so it should probably take you guys around 10 minutes as well. All right. Uh-huh. Mark down exercise two. All right. So this one is a vowel counter. So I want you to create a program that counts the number of vowels regardless of case, right? In a user entered string. So use a for loop and the interpreter to iterate through the string and count the vowels. Or, if you have a different method to reach this answer, that's also good. All right. So your timer starts now. All right, so that's 10 minutes. Anyone has an answer? So we're done with Sir Ryan and Sir Jude, right? How about let's go to Sir Kier and yeah, Sir Kier, do you have an answer?
Hello. Yes. Let me share the screen.
Right.
Hello, sir. Can you hear me?
Yep.
This is my example. So I put my own word which is to input the number in it. To input the word.
All
This is
right.
the part that I put. So I simply because simply put a beginner program. So this is what I use about for instead of and the loop for each character in the sentence. This one with Sharon and this is about this the program that uh, class is supposed to so I enter like a word for example the total vowel here. Two.
All right. Okay.
So
Try another word, another example. Uh, stop the program first and then run it again. Yeah.
the number of vowels reflected zero.
All right.
So
So let's see. Um, so it detects capital letters, small case as well. So I think it's all good. Um, yeah, I don't see any way for me to improve that code. So good job on that, Sir Kier. Let's go to who else? Sir Alex, how about you, Sir Alex? Do you have a similar solution or an entirely different way of answering the problem?
Hello, can you hear me?
Yes, sir, we can.
Yeah, I have a similar, but also did one that's a bit different. So let me just share the screen.
All right.
Sorry. Okay. Uh, Apologies, I'm using ano as a tablet, so I'm not familiar how to. Can I just share the code?
Okay. So yeah, and I'll just load it up here on my end so that everyone can see as well. Oh no, wait, I can't actually I can't copy and paste on the chat.
Oh, okay.
Can you send a file? Can you put it in a notepad and then send the notepad?
Uh, okay.
Or is it difficult?
Wait, I think it's a bit. Wait, sorry. Can you see
Yeah,
my screen now?
yeah, we
Okay,
can see it.
thanks. Okay. So I think this is the first one where I just type in all the vowels in lowercase and uppercase in the on the vowels.
All right.
Then yeah. On the second one, I just input the lowercase, then just put in the loop string that lower to just automatically what do you call this? Put the string into lowercase when it's being iterated.
All right. So that's a good solution as well. So you are forcing the string to be converted to lowercase and then you check it. All right.
Yeah.
Mm. So I don't know which one is more efficient. Whether the string that you're trying to check is longer versus you
Hmm.
converting it to lowercase first and then it checks it with a fewer characters. So I think you're gonna have to run this one in a certain
Yeah.
test app
Case to
to
case.
see which one is much more efficient. But yeah, both answers are actually good. All right. Let's see. What else can I
Thank
say
you.
about this? All right. Let's see. So all of those answers were great. Um, so it's almost 3. We'll have a break first, and then we'll have a different exercise later on. After we discuss about what was it again? Let me share my screen. Let's see. After we discuss text files, I think we are on slide 30. All right, so text files, reading from a text file, and then manipulating text files. So after that, we're done with the PowerPoint and maybe another exercise as well. And we can proceed to the next part of the next PowerPoint. All right. So let's have a quick break, 15-minute break. I want you guys here to be back by around 3:15. All right. And then we'll continue then. All right. So have a good break, everyone. See you at 15 in 15. Hello, hello. All right. Okay. Thank you for the confirmation. All right. Okay. So text files, right? So a text file is just basically what you see in the notepad. That's a text file. And there are a lot of applications in different operating systems that can open a text file, right? Even a programming language can also open a text file by default. So, um, yeah. So let's try this one. Mm, Using a text editor such as Notepad or TextEdit, you can create, view, save. All right. Let's create a file containing 6 floating point numbers. It might look like this. And all data output and input from a text file must be in string format. It must be a string data type. Okay. So if you have numbers there, then you'll have to convert it first before you can use it for your um for any purpose that you want, right? So first let's follow the instruction. Okay, let's create a text file. So I don't know if you guys are using the online I saw one earlier. It was Code Labs. So I don't know if you can create files there, but this is more on local, the example that I'm gonna show you. All right. But you can open one by link, but I think you're gonna have to go through it in a different way. Okay. But the main point is, the example that I'm showing you is if the file is saved locally in your device. Okay. So let's have oh no wait, not here. Should be here. So this is my folder, right? And I want to save these numbers. Actually, not those numbers, any kind of number. So I'm just gonna click new and then text file. All right. And then just floating point numbers, right? 8 point space, just random numbers, just typing it out. All right. Something like that. Um, so 6 floating point numbers separated by spaces. Okay. I think this is good. Let's see. Let's name this one text. Nope. Um, Sample. Yeah. Sample.txt and then save. File save. And then let's close it. Right. So we should be able to see the text file here in the same folder since this is where we created it. Right. Okay. Um, Next part is data can be output to a text file using a file object, right? Take note of the word file object. So we have a new object now, okay? This is the file object. So a file object also has its own properties and its own methods, right? So you have to wrap your head around this, that this is a file object, all right? Okay. Where is it? So we're gonna use the open function in this case, and then it has two parameters. First is the name of the file that you're trying to open, and then the next one is the mode in which you are trying to open the file. Okay. Take note if the data already exists. Python opposite when data are written to the file and the file is closed. Any data previously existed in the file are erased. Okay, this is only for the write mode, right? There are other modes available, but we'll explore them later on. Okay, so first is we're gonna open the file. Right. So we're gonna say with the F is equals to open, and then its name was sample.text, right? And then comma W. Okay. Then afterwards, it's gonna um write the two lines here. Actually, if it's gonna write, it's gonna overwrite the data. So let's see. I think we'll just create another one here. Um, Instead of using sample, right? We'll create a new file, right? And like what it indicated here, if you're using the write mode, if it does not exist, it is created. So that's what we're gonna do. We're gonna create the same thing with as indicated in PowerPoint. Its name is myfile.txt. So myfile.txt. Let's delete this one. All right. So if I run this one, if I run this one automatically, what should happen is I should see that file here, right? So I'm gonna run it. Okay, nothing happens. It just went blank for a bit. But if we go back here, let's see, where is it? Ah, there you go. So I just need to refresh it and I can see that the file is indeed there. Okay, now let's go to the next part, which is how to write things to the file. Okay, so f.write. Now we're using methods for the file object. Okay, let's say that this is my name, Daniel slash n, my last name slash n. All right. And then afterwards is you close it. F dot close. Let's run it. Okay. Open the myfile.txt, and as you can see, it is also stored there. Okay. If we modify this one a little bit, let's say I'm gonna change the last name here to Craig. Daniel Craig. I'm gonna run it. And let's open it up again. And as you can see, it also overrides the data from before. Okay, so this is what you need to be careful of when you're using the write method. Okay. So it always is in this format. It starts with the open, and then you either write or read some things, and then you close it after you're done. Okay, this is the exact sequence. Basically, Python is following how a human would open a file, write something to it, and then close it afterwards, right? When we are done. So it also follows that same format. Open, write, no matter how many write statements we have, and then close afterwards. Okay. All right. So that's basically it. It's as simple as that. But, we're not going to be too dependent on text files in data science. More likely, we're going to be using other mm, other files like spreadsheets in Excel or um, data from the server. Yeah, we're gonna connect to the server, or we're gonna connect data from the web itself, like we're scraping data from the website itself. So that's one of the options that we have. Okay, let's see. Next slide. So the file on the right expects a string as an argument. Um, let's see. So this is just an example of integers.txt. All right. So we are trying to create an integers.txt um, file, right? And we're using the random module for this. Okay. After opening it, we created a for loop that generates random number from 0 to 500. And then 0 to 500. And then we're gonna convert, right, the number data type into a string data type, and then add the /n at the end for each number. So basically what we're going to end up is a series of numbers, right? So let's try this one out. So there was actually no use for the sample.txt. It was actually just plain example. All right, so let's do that again. We're gonna say f equals to open. It was called integers.text, right? And then it was in write mode as well. Then we have a for loop here for x in range of 500, right? And then uh where is it? Yeah, it was using a random module, right? Um, import random, and then random dot rand int, and then save that number afterwards. Number is equals to random dot rand int of 1 to 500, and then save that number to the file object, right? Right, and then hmm, I think we can use an F string for this, right? And then str, I don't know, it's going to be converted to string automatically. So F number and then /n. So there's no need for us to use a function anymore. And then we are gonna close it. F dot close. Wrong spelling. All right. Am I still recording? Yes. All right. Run. Okay, no errors. As you can see, it just went black for a bit. All right, let's go back here, integers.text, and look at that. We have a file now, 500 entries of random numbers from 0 to 500. So it's that easy how to create random data, right? Okay, but right now it's not really useful. We're just showcasing how powerful programming languages are, right? Okay, so yeah, as you can see, it has the same format, open, writes, and then close afterwards. There's an easier method here, which uses the with method, but I actually like this one better because you're forced to remember that you have to close it, right? Um, with the with method, you kind of forgot it, and you have to focus on the indentations. For me, this is actually much more flexible compared to the width. But it depends. Either one is correct. All right. So you might be seeing in other tutorials using the width method, like with open Python. Python open. Nope, doesn't have, but here, where's it with? It's this one. Um yeah, here it is. So this is the format. It looks something like this. So with and then open and then the text file and then pass, just like the aliases that we used before for modules, it also works here as my file. And then um the usual write and read functions that you're gonna use. So as you can see, the only difference is that there's no closing statement anymore. You won't say file my file dot close. After you're done with this section, right? How does Python know that? It knows because it's out of the um it's outside of this group, right? Because the indentations, remember, indicates grouping. So if it's outside this group, then automatically it closes the file. Whereas using this method, you can indicate anywhere after the open, right? when you want to close the program. In this case, it's kind of forced after this part, it's kind of forced to be closed. Whereas in here, it's more flexible in when you want to close the file because you might be needing it later on, right? Or maybe you can actually just open it again or something, but um, I don't know. It just depends on how you're running it inside your head and solving a problem. But that's it. Okay. So if ever you see something like this, it's the same with our open, right? And then close method. Okay. Next is you open a file. Okay, so this time we're just reading a file. Okay. So if you want to read something, then it's gonna have to be using the R mode. Okay. And if the file is not accessible, then it's gonna raise an error, of course. This is true for any kind of file, right? So in here, after opening the file, it says f.read, right? And if you print it out, it's gonna show you the um whatever is inside of the text file. Okay. So we have how many integers, my file, and sample. Let's take a look at each of them. Okay. So f is supposed to open. So let's start with sample.txt in read mode. And then all we have to do is read it, right? Uh, so we're gonna save what it reads into a variable. So I'm just gonna call it temp f.read. Okay. And then I'm gonna print this one out. Temp run. And as you can see, I can see whatever was inside of my sample.txt. Next is we have integers, right? Integers. Right. Now, as you can see, I can access the whole thing, right? And what about the other one? It's my file. Okay, just to show you what it looks like. But I don't know if you guys noticed, but if we go back to integers, it just shows us the whole thing, right? So I don't know if you guys have realized this, but what if the file that was opening was a really big file, like in terms of gigabytes? So if you're opening something that big immediately, right, then it's gonna require a whole lot of memory. Okay, it's gonna um like uses up a lot of memory in order for it to be opened up directly. Okay. And since it's a big file, it's gonna take a while to load as well. All right. So it's kind of like um not very efficient if you think about it, right? So we have another option for this, and it's called the read line. Okay. Now the read line is how do I say this? The read line is used for reading a single line from a text file, just for a single line. So uh it saves a pointer um somewhere in its object that if you call it again, it will point you towards the next line. So that's what it means, read line. So let's try this one out. Okay. No need to be too complicated in its description. It will just read it line by line, basically, read line. So if we do this again, okay, but instead of read it, what we're gonna do is create a for loop for x in mm, f dot read, okay, and then all I have to do is no, wait, I can't use the for loop here. So if you have to use the read, then what you can do, no, wait, it's still gonna save it. It has to be read line immediately, right? So this is actually correct. It's using the while true and then read the line. All right, let's use that method. Because you have nothing to loop over for if you're using the for loop. Yeah, yeah. Unless of course you know how many lines there are. So in this case, the while is the best solution. So while true, right? We're gonna say f dot read line. I've got line is equals to f dot read line. Yeah, this is the line is equals to f dot read line. And then, of course, since we're in a while loop, you're gonna have to indicate when it will end. So you're gonna have a condition here, if, and then line. So this is the part where you will check if it's actually a space, right? Then you'll have to break it out. Otherwise, then you'll just have to print whatever is inside of that line. And then this is the part where you close it afterwards. All right, so if we print this one out, all right, you can see that we also have this kind of output, but why does it have spaces? So it's reading the slash ends. Oh. Mm. So if we can remove it, can we try using read line? Okay, line is equals to print line dot strip. There we go. All right, so I just wanted to be the same format as above. So what happened earlier was that it's also reading the slash n character at the end, so that's why it's having spaces in between. But you can remove those things using the strip method for strings. Yeah, so it removes white spaces and um the escape characters, the slash n, those kinds of things. All right. So that is what the read line is. Again, this is more efficient in terms of handling memory, okay, because you can process each one line by line, whereas this one has to save the entire thing in memory, okay? Reading numbers from a file. So this is actually pretty simple. We just have to convert it into an integer. So as you can see here, integers, right, for line in F. Line the strip. So, oh, you can actually do this one. All right. So instead of using the read line, you can just skip that one and use a for loop directly. And you can read it line by line. So it's already set by default in Python. So you don't, this is actually not needed anymore. All you have to do is use a for loop and it will read it line by line. So if we just um yeah, it's using a for loop and then there's no need for an if. Yeah. So all you need to do is this one, the strip part, which is what they have here. And then the moment that the file ends, it will exit out. Okay. And then you get the sum because they're trying to get the sum of the number here. So let's try this one out. Let's just copy and paste this. All right. So it's using a for loop, right? For x in F. So we have the file object. We're reading the file object directly, right? Yes. And then we have the sum of 0, the sum equals 0. All right. So for x and f, then all you have to do is the sum of a plus equal to int of x, right? And I want to print it out as well. So x dot strip, there you go. And then I want to print out the sum here as well. The sum, enter, right? And at the very end, we have 119,353 in total, all right? So I hope you guys understand this one. Again, how do I minimize this? Minimize. Oh, never mind. But what's important is that both solutions are still correct. But in this case, you're adding an extra step because you're using a read line method. Whereas in this case, we're just reading the file directly. So for loop is actually capable of doing that, reading the file object directly. Okay, line by line. All right, so the next code segment modifies the previous one to handle integers separated by spaces and or new lines. All right, so it's just, okay, so there's just an extra step here. It splits them out because what the numbers are separated by spaces or new lines. It splits them out, so what you get is the actual number in string format. And then all you have to do is loop over that list, which is what it's doing here for word and word list, and then convert it into an integer and then add it to the sum. So it's basically just the same. It's using the same file, integers.txt, but even if you split them out, mm, okay, I get it. Actually, it doesn't matter even if there's spaces, because once you use the int on it, it's not going to recognize the space, only the number part. So it's still correct. We can still use our solution here, right? The only thing is that if you have something like this one, the sample.txt, this is where this one becomes useful because again, you have the split method. So it splits this one up for each line and then add each one to the sum and then goes to the next line, right? So some data sources out there are in specific has a specific number of values, items in a row. Like for example here. So it's separated by spaces and then there are 8 numbers on each line. So if they are in that specific format, of course you can actually just use the split, right? But again, usually there's another character that's separating each number. So odds are it will usually be colon, sometimes it's double colon, sometimes it's dash or slash, all right, it depends. Sometimes there's a dot, I see a dot, or in this case, a semicolon, this one. Comma, I don't see that one a lot, or data sets. Yeah, so those kinds of things. Okay. So these are the functions that we have been using so far. So open, close, write, read, and read line. Okay. Actually, I think we forgot something. There's something called append. So that's an A. Let's go to my file.txt, right? Let's use that sample. All right. So my file.txt. So if you were using the append mode, that is A, right? And then if you were to write, okay, and then I were to add someone like James Bond, for example, and then I were to print. No, 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 no. I'm not gonna write it there. Oh no, I'm gonna write F dot write and then F dot close. No, 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 wait. Let's print it out. Print F. Mm, Did it work? Let's see. My file. Was it right? Oh no, wait. It's a pen. All right. Let us use Google for this one. A pen. Let's see. Open method. Right, so it has a pen, opens the files and creates the files if it does not exist. All right, should be somewhere around here. Well, just not. Forgot the exact name of the uh all right, so if we don't have it, then we can just use dir. F. Let's see. Close detach error slash name read line seek write. So there's no pen. So it's just a regular write. Oh yeah, there we go. So it actually created it the one earlier. Left that close. Right. So all we have to do is open and close it again. And it's not working. James, okay, there we go. So it just takes some time before it adds it, but it will be added. Okay. So it's not actually the append method. You're still going to be using the write method. Okay. And then it has to be in the A mode or append mode, right? Let's see. But again, some resources are not complete like this one. It has the options, but it doesn't show you how to use them. Maybe it's somewhere in here, I don't know. All right. Accessing and manipulating files and directories on the disk. All right. So this is actually very simple. You're just referring to a file either in absolute path name or a relative path name. So when you say absolute path name, the chain starts with the root directory. Okay. And when you say relative path name, the chain starts from the current directory or where you are currently working. Okay. Now, um, in this graph here or in this picture, um, you'll see some names, right? So in here it says Lambert and then parent. I wonder if there's a bigger one. Yeah, there's no bigger one. You start with Lambert and then parent, and then under parent, it is divided into my file.txt, current, and sibling. So you notice the colors. The one in gray, they are the folders. The one in white in background is a file itself. So under the parent, there are two folders, current and sibling, and then there's also a text file. Under current, there is another folder called child, and then another file called myfile.txt. Under child, there's also myfile.txt. Under sibling, there's also myfile.txt. So all of them might be the same, but we're just essentially showing you what it would look like if they are found in those specific places. All right. Now, let's say that you are going to be using the relative path name. So it depends on where you are currently. So in this case, current, this is where you are. Okay. So if you're gonna go to the child, then you're gonna have to start here. So start writing your path name using this as a reference, your current folder that you're working on. Whereas if you're using absolute path name, then you're going to have to indicate it using the one at the top. Okay. Now let's go and have examples. Okay. Using this one as a reference, the current, right? You're here and then you're trying to access the child. So this is what happens. Okay. So you say child, you're accessing the folder and then my file.txt. Okay. And then it's just in read mode. If you're trying to access the parent, right, all you have to do is use two dots at the beginning, and then it will automatically go to the parent. So this is still correct, okay? Go to the parent and then myfile.txt, which is correct. We are currently in this folder. Go to the parent, all right, dot dot, and then go to myfile.txt. So this is correct. Um, if you want to go to the sibling, then you have to go to the parent first, then to the sibling, and then to my file.txt. All right. Um, let's see here. So I don't know if you've noticed, but yeah, okay, sir here. I actually didn't catch his. Okay, you're still here. Yep, sir. Yeah, you're free to go. I'll just upload the recording as soon as I can. All right. Goodbye, sir. Okay. So where were we? Right. Sibling file. Okay, so you're gonna have to indicate the root folder. No, the parent first. So dot dot. That's how you indicate the parent. And then go to sibling. Okay, parent, sibling, and then my file.txt. Okay, so that's how you should do it. All right. Let's see. Mm, hmm. All right, so this is actually not really important for us because most of the time we're not gonna be um let's see. We're not going to be interacting with the operating system. So that's what the OS is for. So if you import OS, this is a module in Python where, again, it provides a way for us to interact with the operating system and perform various operations relating to the operating system. Um, if you like to work with the files, directories, and then the underlying systems, as well as execute system commands from Python, then this is where you would like to go, the OS module. But again, um, we're not going to be manipulating or accessing or using any of the commands in our operating systems in data science because what we really need is from a different library. So we're going to be using something like pandas, matplotlib, those kinds of things. All right. So let's just breeze through this. Okay. So let's just breeze through this. Basically on the OS file, OS module, um, one of those functions or methods is called get CWD. So CWD is short for current working directory, right? And then list dir is basically just a method that lists down um, all the files and folders within that directory. All right, so you kind of get what it's doing here. Get the current working directory, list out everything that's in that directory, and then create a for loop, and then look for the files with a .py in in their names. So basically, you're filtering out which ones are Python files, Python scripts. But you can just actually do this directly using Windows Explorer, right? Or any kind of Explorer, depending on what you're using. Um, but we're just using this. We're using it. You're using Python to do the same thing. Okay. All right. So these are the other um, methods available. So we have chdir, so that's change directory. We have mk, that's short for make dir. Remove, rename. Rm is remove dir, yeah. And then sep is the separator. All right. The naming patterns here is similar to what you would see if you were ever using Linux. If you will ever reach that time where you're going to be using Linux, you're going to be familiar with these naming patterns. If you're ever going to be using shell for accessing system resources, you're going to be familiar with how these names are made. But right now, again, really, it doesn't really matter for us. So we have exist. It checks first if the path is um, var. It's if the path actually is there. Because if it's not, then it's going to return an error. And if it's an error, then it's going to stop your program. So this is one way of controlling that error so that it won't stop. Next is checking if it is a directory or if it's a file. You can get the size of that directory as well. And norm case is you will convert the path name appropriate to your current file system. So basically it adapts itself to whatever operating system you're using. So if it's Windows, then we'll use forward slashes and letters to lowercase, right? Okay. Let's see. Oh, okay, chapter summary. Let's see. Should we have an exercise for this? What time is it? It's already 4. So I don't think we've discussed something that big already. Let's see. Let me review it. So we have writing files, right? So not really that big. Reading from it, appending from it, and then the path names. So I think we can just skip this one for now. Let's go directly to the next PowerPoint. This one. All right. So this one is more focused on lists and dictionaries themselves, okay? Okay. So a list allows a programmer to manipulate a sequence of data values of any type. A dictionary organizes data by association rather than by position, right? So this is where we will be focused more on what lists are and what dictionaries are as well. Okay, all right. Let's start first with list, okay? And we call the things inside of the list items or elements. Here are some examples of some analogies. So we have shopping list, to-do list, roster, we have guest list, recipes, you name it. Each item in the list has a unique index. We already know this one. We have explored this one before. And it starts from 0 to length minus 1. So whatever the length is, minus 1, because again, we are starting from the number 0. We're not starting from 1. If we have to list down the properties of a list, like not properties of the object, more like what makes a list a list. So first is it has to be ordered. Why? Because there's a sequence, right? Um, it's mutable. So when you say mutable, you can change the things inside of it, right? You can manipulate it, swap values with it, right? What else? You can have a mix of data types. That's one of the things. And then accessing it is as easy as also using the subscript operator. So that's one of those properties as well. Okay, so here are some examples. Um, Here's a list of fruits. Here's a list of a pair of numbers, pairs of numbers. So list of, there are lists inside of lists, okay? And each list is composed of two numbers, 509, 541, 78. You can do that one. So what kind of information is something like this? Maybe it's latitude and longitude. You can have that one. There, it's only two numbers, right? When an element is an expression, its value is included in the list. So just like with functions, right? Python has to evaluate expressions first before um executing the function, but in this case, it's before assigning the value to the list. So math that squared x here is an expression. So it has to evaluate this one first, and it's equal to 1.41. So that's why when we print this one out, what we see is the result already of that expression, okay? Same as this one, x plus 1, so it becomes 3, okay? Range. So if you were to use the list function on the range, what you would get is basically a list of numbers from starting point to end point. We've done this before already, right? Um, so yeah, if you want to make a quick list of, you know, numbers that are from a certain point and ends at another point with a specific interval, then you can use this method, okay? You can also use the list method on strings where it will separate each character um, as different items on the list like this, okay? Len subscript operator plus an equal works on list as also expected. All right, so most of the things here we have already used before actually. So len, subscript, um, subscript operator, but you're splicing it. You're choosing from and where it will end. Concatenation, of course, equality. So if you were to add first and then the number 5 and 6, so the first that it meant here is from the previous slide. So it's 1, 2, 3, and 4, right? 1, 2, 3, 4. And then if you were to add 5 and 6, then it will become something like this. If we were to equate first is equals to second, then it's true, right? So don't be confused with this. We added the first and then another list of 5 and 6, which gave us a result of 1, 2, 3, 4, 5, and 6. Makes sense. But we did not assign this one back to the first variable. So in this second part here, the first here is still equal to 1, 2, 3, and 4. Okay, so that's why if you equate them, is first equal to second, what you will get is still true. Okay, so don't get confused with this part. To print the contents of a list, then you can just go directly and print it. It will just be printed out as a list. But this is also in string format already. The in also works for a list if you're trying to look for something, right? You remember the in operator. If you're looking for a substring and another string, you can use the in. The same thing works with list. So if you're looking for a specific item, then just search for it using the in operator. All right. So a list is mutable. Okay. When you say mutable again, elements can be inserted, removed, or replaced. That's what it means. The list itself maintains its identity, but its state, length, and contents can change. Meaning, even if you change anything inside of the list, it will still be a list. It does not become anything else. It's still a list. All right. The subgroup operator is used to replace an element. Yes, we've done this one before, right? So example, and then you're accessing the fourth index. Oh, no, a third index. So this is the fourth item is equals to 0, and then it is changed to 0, as you can see here. Okay. Subscript is used to reference the target of the assignment, which is not the list, but an element's position within it. So yeah, it just describes what we're doing here. Basically, we're indicating what element we're trying to access based on the index number, right? So again, nothing really new. Most of this stuff is, we've been using before. Um, all right. Okay, so this is slightly different. Um, so we have numbers, right? And then for index and range len of numbers, okay, in this case, you're trying to generate a list of index, right? So you have len. What is the len of numbers here? It's 4. There are 4 items, right? But the range here, if you remember, um, will give out numbers starting from 0 up until the number that you put, but not including that number. So if you put 4 here, the range of 4, then what we'll have is 0, 1, 2, 3, 4. 0, 1, 2, 3, which coincides perfectly with the indexes that we have here on our list, 0, 1, 2, 3. So with that, we can directly say we're going to call the list, enter the index, and then we're going to assign it its new value, which is just the number itself to the power of 2. So this is now the result if you print it out after that loop. 2 to the power of 2 is 4, 3 squared is 9, 4 is 16, 5 to 25. All right. So yeah. This part here uses the string method split to extract a list of words. Okay, so this is our list of words, this sentence. We're gonna split them out, so we're gonna have a list. This is our list. This example has 5 words. Each one is separated by their spaces using the split method, right? Next is for index and range len of words. So the same thing as what we did here. So len here is 1, 2, 3, 4, 5. Range of 5 will give us the numbers of 0 to 4. So 0, 1, 2, 3, and 4, right? So access the item using the index, and then assign a new value to that same item, but now it's in uppercase because we're using the upper function. So it's basically converting it to an uppercase, okay? So this example has 5 words, all right? So these are the other methods for the list, right? So we have append. You can add an element at the end, extend, so as the element of a list to the end of L. So it's basically just the same as using the plus when you're adding list, right? Insert is you're going to indicate the index and the element where you want to insert that element from the name itself, right? Insert. Pop removes and returns the element at the end of L. So if you have a list, whatever is at the end, that will be popped out, hence the name pop. If you say pop and then you're going to input the index, then it's going to pop out that specific element or item in that index number. Okay. So let's see. The method insert, right? So it's very straightforward actually. So insert at index 1, the number 10. So 0 and 1, right? So 1, this is index 1. I want you to insert 10 here. So the moment that 10 is inserted, it will move all the numbers to the right. Okay, it's just as simple as that. The example is inserted 3, 25. So 1, 2, and 0, 1, 2. 3 doesn't exist, but Python understands that one. So all it has to do is add it to the end. All right. That's what the insert. The append here expects, and the new element will be added at the end of the list. All right. So it will always be at the end of the list. Um, let's see. The method extend performs a similar operation but adds the element of its list argument to the end of the list. So let's see. We have an example here, 1 and 2. If you were to append the number 3, it will look something like this, 1, 2, and 3. If you were to extend it with this list, 11, 12, and 13, it would look like this, 12, and 13. If you were to add 14 and 15 to this one, then it will look something like this again. So 1, 2, 3, 11, 12, 13, 14, and 15. So as you can see, extend and adding it basically will have the same result, right? Okay. The difference is that mm, what could be a difference? So since we're using a method here, this can be more dynamic. Like you can use a variable here, and then you can just dynamically change the value of that variable at any time, at any point in your program. Unlike this one, where it's basically hard coded. So you can't edit it anymore. It will always be 14 and 15 that will be added to the example variable. Whereas in this case, extend, right? If this was saved in a different variable, mm, actually, yeah, you could just use a variable here as well. Mm, performs a similar operation to the end of the list. This will still add it to the end of the list. All right, so I think I got it. So this is just making sure that if you're using the extend, so it's not actually for the variables. If you're using the extend, you can be sure that what you put inside here will be added to the end. Whereas in this case, you can sometimes swap them out. So if 14 and 15 was at the beginning, right? Like for example, this one. So you have 14 and 15 here, and then plus 1 and 2, right? Um, if you were to add them together, this is what it will look like, right? But if you were to swap them out like this one, all right? So they are now different things. But if you were to say um, dot extend, so if you were to say 14, 15 dot extend, right? 1 and 2. Okay, so I can't actually print it out. It has to be inside a print. Incomplete input. Why? This one. Oh, it won't actually do it. All right. Mm, let's see. Let's try and save this one in a variable. Temp. Yeah. Okay. Uh, temp dot extend. So this has no return. So all I have to do is print the temp itself. Yeah. There you go. So this just basically ensures that what you put here will always be will end up at the ending part of the list. Okay. Mm, yeah. So I think that's it. I really don't see anything else that we can have an example of that. All right, let's go to pop. As user move element at a given position. So this is our example, right? If you use the pop method, automatically 13 is removed, okay? You will get the value of 13 if you save it to a variable, but usually you're removing something because it's not used anymore. So whenever somebody is using pop, it's usually just for removal purposes, not because they have a use for that number. Okay, so I hope you understand. If you're trying to use that number, you could have just access it using subscript operator, right? Instead of popping it out. So you're essentially removing it from the list. Okay. Um, in here it's indicating an index, so pop 0. So 0 is 1, right? And as you can see, the example now is left with 2, 10, 11, and 12. Okay. Searching a list. So the in operator again indicates element's presence or absence, but it does not return the position of an element. So basically, it can just check, just a quick check if it's inside of the list. All right. So what we need to do to determine the location is that we can use the in as a sort of initial check. If it's somewhere there, then we can use the index method to look for that specific target, right? So in this case here, we're looking for the number 45. So first we check if 45 does exist in the list, which it does. Next is we're gonna use the dot index method and then type in the target value. The target here is a value, not the index, because what we're looking for the index number, right? So in this case, what we'll return is 1, 0, and 1. So that's what we'll get here. Okay. So let's see. You might be asking, what's the use of the if statement here? Again, if statements are great if you want to control how the program handles errors, right? Because if you were to use a list index and then the target doesn't exist, then this will return an error. So if there's no way to handle the error, then your program will stop, which is not exactly what you want, right? So that's why we have an if else here. And then this is printing out -1. This is pretty common in programming. When you see -1, it also means it doesn't exist. All right. So that's usually the case for -1. Um, sorting a list. All right. So if we have, let's say, a list of items, we can impose a certain order to them by sorting them out, whether it's by ascending or descending order. Okay. Um, when the elements can be related by comparing them using comparison operators, they can be sorted out. So we have the method sort mutates the list by arranging in ascending order. So in ascending order, that's the default. Okay. That's the default behavior of the sort method. So we have 4, 2, 10, and 8 here as a list. And as you can see, by using the sort method on that list, it is transformed to 2, 4, 8, and 10. Okay. All right. Let's see. So if there's something to be careful of with sort is that if you've noticed, the original value of example is changed, right? So here it's 4, 2, 10, and 8. If you sort it out, it becomes 2, 4, 8, and 10. So essentially, um, they are not the same thing anymore because they have what? A different order, right? So um the sort method is actually a function that results in a mutation of the original value. So this is your original value, right? By using the sort, you are um, changing the original value itself. So in programming, we have this kind of rule that you shouldn't really change the original input from the user. What you do is make a copy of that input, and then you're free to do whatever you want with that copy. But the original should still exist because, just in case you need that input again, you don't have to ask the user for the original input, right? It doesn't make sense. It's like someone is paying using their credit card and then you lost the number because you mutated the number. You're not gonna ask, sir, can you swipe again? Because you know, that's just gonna, it will just lead them to distrust you, right? Why would they swipe them again? Because we've already swiped it once. It should push through, right? So that's one of the things that you need to avoid. So we have mutator methods here. That's why I explained that one because of the other mutator methods that we have. So in insert, right, the one that we had earlier, can also mutate the original one. The append, the extend, those things will also mutate. So any function or method that changes the original value, okay, is a mutator function or method. All right. Um, let's see. So yeah, so all that is trying to say is that if you're using the sort, it returns a value, but just like with the pop, right, it returns what you're trying to remove, but there's actually no use for it. So if you try to print it out, it will just come out as none. So there's really no need to pay attention to this one. Aliasing. All right, let's go to aliasing. Okay. Um, let's follow this example. So you have a variable first, and then it has a list of 10, 20, and 30, right? And then you have a second variable here named second, right? And it's equal to the first. So they should have the same value, right? So if you print out first, you will see 10, 20, and 30. If you print out second, what you will see is also 10, 20, and 30, right? If you were to change the index one of the variable first into 99, then what you would get is something like this. First is 10, 99, 30. Second is 10, 99, and 30, all right? So what does this mean? This means that both the first and the second are referring to the same object, which is this one. And in terms of memory, it's looking at the same location, right? They're looking at the same location inside of your memory. All right. So this is what we call aliases, right? They are aliases of each other. They refer to the same list object inside of your memory. Okay. All right. Um, to prevent aliasing, you can create a new object and copy the contents of its original. The same with mutator methods. You can copy the original value, save it to a different variable, and then play around with that one. All right. So in this case, for elements in first, third that append element. So we have a blank list here, and then we're just appending to the list whatever element is in first, right? So this is a very roundabout way of copying things because it's using a for loop. Um, I'll show you guys something else later on that's better. Okay, so let's finish this one. So we have first, right? 10, 99, and 30. We have third. which also is 10, 9, and 30. Now, they have the same values, right? But they are saved in different variables, different locations in memory, right? So if I will modify the first index 1 into 100, right, and then print out their values again, they will have different values now, okay? Because again, they are both referring to different objects in memory. Okay. For copying things, this is actually better. So if you want to copy, there are various ways. You can copy using slicing. Like, I'm gonna say this is original. This equals to 1, 2, 3, and 4, right? If you want to copy this one, then you can say copy is equals to original, and then just do this one, right? So a single column with no values on left and right side. If you print this one out, right? It will still be the same thing. Okay. If I were to change, right? So I have a copy now, right? So I were to change copy of index 2 into 10, and then I were to print it out again, both of them, original, and then copy, just so that we can see the difference. And as you can see, they are now different things, right? So that's one way of copying. Another way of copying is um, list constructor. So, or the list method. So you say list of original. This will original. This will still create a copy of the original, right? So as you can see, if I run this again, it will have the same result as the top one, all right? So using the list function will create another copy. Um, what else? We have the copy method. We have the copy method here. Um, so you have to call the original and then that copy, and then that's basically it. So it's just a method. And now you have two different copies of the same thing. All right. Last but not the least, it's not really that useful because you're gonna have to import it, right? So you're gonna have to import and then the copy module, and then what you need to do is call copy, and then I think it's called deep copy, and then you pass in the original here, and then that's it. So as you can see, all four methods works, okay? You can copy list by slicing, using the list function, using the copy method, and using the um, copy module. Let's just go to this one, copy method, list function, slicing. All right. So yeah, just refer to this one uh, when you review your notes, okay? All right. Object identity and structural equivalence. All right. So it's quite far from lists and dictionaries, right? But it's important that we identify this one early on so that we can avoid creating mistakes in our programs that um that can be avoidable. So let's see. So programmers might need to see whether two variables refer to the same exact object or two different objects, like the one earlier, the aliases, right? So um the equal operator here returns true if the variables are aliases of the same object, but it will also return true if the contents of the different objects are the same. So there's no way to differentiate using the equal sign whether the two of them are of different objects, right? It would be good if all you were trying to do is trying to compare the contents. But if you're trying to also check if they are the same object, then the equal operator does not work. All right. So the first part here, all right, it's called object identity because they are referring to the same object. The second one is called structural equivalence. Okay, so it's a big name, but basically it's just the same values, right? The equal operator has no way of distinguishing between these two types of relations. So what is our solution for this? We have the is operator. Okay, now we can use this one to check for object identity. Object identity is what? Is for checking if the two objects are aliases of each other. Okay, now we have a first variable 20, 30, and 40. Second is equals to first. Third is equals to list of first, okay, or basically just a copy of first. Okay, now is first equal to second? True, because they have the same value as well, and they are also aliases. Okay, is first equal to third? Yes, they have the same values, but they are not aliases. But we have no way of identifying that one, right? Using the equal. But if we're using the is operator, first is second, then we know now that both of them are aliases and they are referring to the same thing inside of our memory. Whereas in this case, first is third, right? It will return false because they are now referring to different things. Okay, this is the first, this is second. They have different locations inside of our memory. Okay, so one will not affect the other if you were to change it. Okay, median tuples. Why is the median here? All right, so it's using a list to find the median of a set of numbers. All right, all right. So the median, right? If we search this one, what is the median? So this is a statistics term, median, median. I think my keyboard is out of battery. Median, okay, a set of numbers, values separating the higher half from the lower half, okay? So we're gonna be using this term a lot in data science. So basically everything that you've learned in your statistics class, like the mean, median, mode, um, the different statistical analysis, you're going to be doing that one as well. But of course, with the help of libraries to make things even easier. Okay. All right. So let's analyze this one first. Um, hmm. So we're going to ask the user for an input, right? And then we're going to open a file, input text, convert it to numbers, and add the numbers to a list. All right. So we're going to open the file. We have a blank numbers variable here. It's a list. And then for line in F, basically each line, we're gonna split it out and then append each word. So it's just using split here so that the slash ends will be separated. But basically what you'll end up with is a list of numbers. Basically it just looks like what integers.txt looks like. Okay. But it's in a list format. So now we have a new list, right? And then what we need to do is sort it out. So numbers that sort. Again, this isn't good practice. What you need to do is create a copy of this. So numbers that sort. And then midpoint is equals to len numbers, floor operator, 2. So, oh yeah, you're trying to check if you're gonna divide the number of items by 2. If it's equal to 1, then there's only one number at the middle, right? But if it's an even number, when you have an else here, then what you will do is you will get the number at the midpoint and the number before the midpoint, add them together, and then divide it by 2. That is your median, right? So at first glance, it kind of looks like it's complicated, right? But all you have to do is just read it line by line, separate it by sections, and then it becomes easier, right? Of course, at the beginning, it's going to be difficult because um, you're not yet super familiar with all the functions. Okay, so I'm reading this one as is, right? As what is on the PowerPoint. And yeah, yeah, it just needs constant practice to read out what it says with just by um a single look. All right, because you're gonna reach a point where um most of the things are gonna be a repetition. Like the moment that you see a for loop, I don't have to read the entire line because I know that in my mind, okay, it's gonna loop over what? Okay, it's gonna loop over F. What is F? F is a list. Okay, so let's try to look at each item. All right, what is it doing? It's splitting up. All right, so it's trying to check or remove those extra spaces. So that's the way how I process when I'm reading code. Okay. Of course, it takes a lot of practice to do that. Okay, let's go to tuples. All right. Tuples resemble a list, but is immutable. All right. So this is the opposite of mutable. When you say immutable, you cannot change, insert, or append or remove actually any items from that list. Okay. So list is for brackets, right? Tuples is denoted by open and close parentheses, just like a function. Okay. So don't get confused with them. Here's an example. Fruits is equals to apple or banana, right? We have meats here as well. We can add two tuples and it will create a new tuple as well. All right. If you have a list, veggies, in here, and then you use a tuple function on it, it becomes a tuple. Okay. If you use a list function on a tuple, it becomes a list, and vice versa. All right. So just remember that one. Okay, there you go. Again, so if you have temp here, right? 1, 2, 3, and 4. Okay. And if I were to use tuple on this one, tuple on temp, run it, it becomes a tuple, right? But what if in the future you want to change what is inside of that tuple? So you can't change it immediately, right? You can't do something like this. 3 is equals to 78. It's gonna return an error. Cannot contain assignment. Perhaps we meant equal equal. Okay, so syntax error. Um, so yeah. Let's see. Tuple, right? So this is now tups. This equals to tups, right? So temp is converted into a tuple. This is what we got. But if you want to get it into the something like that list, um, and you were to convert it into a list again, tups, right? List. Okay, so it becomes a list again. So if you ever want to change the value inside of a tuple, you have to convert it to a list first, and then convert it back to a tuple afterwards. Okay. Now you might be wondering, sir, if it's immutable, right? Does it mean it's for security purposes? Like that's what usually is these things are for, right? If you want something that cannot be changed, immutable, right? It's usually for security purposes or something, but that's not actually the case. Usually for tuple, it's for um, accidentally editing a list. So for example, you have a list of configurations saved somewhere in your program. So you're gonna save it like config, and then you're gonna save it into a list, for example, but you want it to be a tuple, okay? Like the first item is always gonna be the is it gonna be full screen? Uh screen, or is it gonna be um the volume which is at 80? Or maybe the codec that it's using is I'm thinking of a video file configuration for this. So full screen, 80% audio, um, what else? Seek. So it's gonna start at the beginning. So I'm gonna say 0.00 for the timestamp. Um, what else can you see in videos? Does it repeat in after it finishes like a loop? So it will either be true or false. I'm gonna say false. Okay. All right. So this prevents us from making a mistake like saying uh config one is equal to mini player, for example. All right. So it's gonna give you a type error. Does not support item assignment. So it just helps you avoid accidents like this one. Because when the code gets too long, right? Um, you actually kind of forgot sometimes, right? So this is a good way of protecting your values. Okay. So defining simple functions. By the way, tuples also have their own methods. If you search it, okay, tuple methods. Yeah, so tuples have their own methods. Okay, but it's only a few, count, index, because essentially the tuple is just a list. So most list methods also work with tuples. Okay, like for example, if you were to uh loop over this one, right? For x and config. No, wait. Yeah, let's actually try it out. List methods, just to be sure. Count, copy, clear, index, pop, remove. Okay, so pop, not allowed, remove, reverse, nope, sort, nope, extend, cannot. All right, so that's why there was only count and what was the other one earlier? Forgot the other one. All right, so yeah, most of the things here are actually not allowed. So only those two things are leaving. But anything else that we can do is also possible. Like this one, we're gonna access it using a for loop. We can do that one. Config, right? And then let's say x dot upper, okay, print x dot upper, something like that. So we can still access it in a way. We can also save it on a list if you want, right? By copying it and then saving it as a list. Let's see, slide 26. I think we'll end it here for now. We're kind of at the midpoint of this PowerPoint. So PowerPoint 5, slide 26. Slide 26. All right. Just so that I won't forget next week. All right. So, any questions so far? So I think we lost one. I wonder who was that.
A question, sir.
Yep.
Yes. We some happening five lessons of this
Mm.
coding strong.
Sir,
How
I can't.
how can learn everything
Sir, I think you have a choppy
in
signal.
in
I can't really. It's gone. Let's just wait for a bit. How about you guys? Sir June, Sir Ryan?
Okay, hello, hello again.
Yeah, it's clear now.
Okay, now we have learned so far the plenty of functions
Yep.
with the len, the tuple, and then these, for example, and then print function like that. How and then how can we well, because how can we make practice make perfect for with this one? Because how can we learn everything with the or compress everything, because we don't we I don't I will not get it right away in one sitting like that.
Yeah.
Yes.
So I'm also the same when I was just beginning learning. So it's actually a lot of information to take in, right? Like 4 hours is not enough so that you can be familiar with it, even though it's easy to understand. Applying everything that you have learned so far into actual solutions is actually quite difficult. Okay, that's the trick, right? Because programming is still a skill. You're gonna have to use it in order for you to become better. So if there are some tips like avoid memorizing things for me. That's what I did. Because there's always gonna be more and more things to memorize, especially later on when we start doing the data science part. Okay, the difficulty will go up. Okay, it will go up, and then you'll realize immediately that there are so many more functions that you need to um learn, right? So at first, it's gonna give you some burnout because you're gonna be thinking, okay, I'm gonna memorize everything or something like that, right? So try to avoid that. And what you should do is understand the process of how it's going, how it's working, right? Like um focus more on what are the data types that you are trying to work with, and then focus on the number of objects that you're trying to work with. Because if you narrow it down to those things, right, the objects, the data types, it's actually fewer and fewer things. And if you take a look at resources like this one, okay, and if you go to Python, I think, all right, let's try and get into this part. Okay, they actually filtered it out into easy to identify sections, right? Like, for example, if ever you were trying to search for string methods, they already have it here. List methods, they have it here. Tuple, set, and all the other references, built-in functions, right? If you want to learn about modules, you have this one here. So, what I do is that if I memorize something, I did not memorize that one by intention, more like I memorize it because I kept on using it, something like that. So what I always remember is that um, what I kept in mind is that okay, I'm working with Python. I have these modules available for me. So whenever I encounter a problem that requires me to access a website, for example, okay, I remember that there's a module for this. Okay, so I'm gonna go here to this module. I'm gonna scan it for a bit and look for the things that I need, and then apply it afterwards. So only then do I start learning a little bit. Okay, only the things that I need for my specific problem. Then after that, it just depends on whether I'm going to be using it again in the future for a different problem. But odds are, if you use it once, then you're going to be using it again afterwards in the future. So focus more on those those kind of thoughts, like what are the objects that you're working, what are the modules that you're working. Okay, if you're working for lists, right? So just remember that these are all the list methods available. If you are working on strings, okay, just have a quick read on each method, and then you'll somehow remember it at the back of your mind. Like, I think I read somewhere before that there's a function for this. Maybe I can search that one. And then you go back to your reference. Okay, hey, there's actually a function that's called let's see here. Let's look for something that's a bit hard to use. Where's regex here? Regex. Okay, it's not here. It must be somewhere else. Okay, maybe you have a problem that checks if all the characters that the user inputs are actually letters and numbers. So, and you've read before that, I think there's a function for that where if all characters in a string are in the alphabet, or if they are alphanumeric, in this case, letters and numbers. So you have this one, SL So this is the moment where I will come back to my references and check if there's a function for that one. And then, study it for a bit and then use it afterwards for my solution. Otherwise, then if there is no immediate solution, like a function available for it, then that's the time that I will create my own. Because if you were to create your own, it will take a very long time, actually. So I don't know if that answered your question, sir. Because, I've been in this for quite a while now, and it will never disappear, that feeling of like you don't know enough or something. So yeah. If you want to practice, here's what I can suggest. So I'm not advertising this one, but this is what I used before. All right. So we have something called Code Wars. Not us, I mean somewhere in the web. This is actually good. I used this before. So they start you out at the very beginning, okay, and then give you some challenge questions, like exercises, for example. Um, so what you need to do is choose your language and then just choose fundamentals at the beginning because it focuses more on the core concepts, and then just keep on train. Uh, Click on train, and then it will give you problems. It will check your answers if it's correct, and then you'll get to see other parts of the programming flow, right? Like there's a text test code there that you can see on how they test your solution, right? If it's correct. Um, the best thing about this one is that you can compare your solutions with others. So after answering it, or after you decided I can't answer this anymore, I'm gonna abandon this one. I'm gonna check the answer, what the others did. So you can do that one, and you can learn more by reading the answers of the others. Like, oh hey, I didn't know that this was actually possible, where you can create a list based on something that is true, like list comprehension. Um, like, let's see for this one. Let's see. Okay, so I can create one directly here, but list comprehensions, like it will create a list, but it's just in one line, like a really cool shortcut or something. Um, Others may be using a library that you do not know about, that made it easier for them to solve that problem because a function was already provided or something like that. All right, so you can go to here. It's actually free. There's no need to pay for it. And yeah, you can just keep on training here. Maybe one problem, two problems a day, that will be good. It will just, keep you um well trained. So these are the test results. Like it works with this test, but it didn't work with this. It didn't work with this. So you need to modify your answer a little bit. It has some ranks if you're into ranks. What else? Let's see. Yeah, aside from that, you can check the answers from the others. So that's actually the best thing about this. All right. So I hope that answers your question, sir. How about you, Sir June, Sir Ryan? Is everything good so far?
Yes, sir.
Right. So I think that's it for this week. I'll try my best to upload it as early as I can, and then I'll see you guys next week. Okay?
Sir,
Yes.
is there a way we can download the PowerPoint on your learning management system?
Okay, sir. So actually, before we allowed that one, but we've recently had new shall we say we do not allow actually anymore to download for students to download our PowerPoint. So we want them to actually to go back here
Yeah.
in our LMS. But maybe you can ask for special permission from Miss Mariel. But from what I know, this is how they want us to present our PowerPoint. So it's still
Okay.
available, but
Okay.
you're just gonna have to view it here on the LMS.
How about if after the training, is this still accessible?
Yes, from what I know, this is a lifetime access. So all you have to do
Okay.
is just tell them that you've been in this program before, and then you'll have access to everything that we have used here.
Okay, sir. Thank you, sir.
Yep. All right. So that's it, guys. Thank you for participating and listening to the discussion. I'll see you next week. All right. Goodbye. Happy weekend.
Bye.
Thank
Thank
you,
you
sir.
very much. Happy
Thank you,
weekend,
sir.
Professor.